Hi and Assalamualaikum. Me and my friend want to present our lab report titled Phase Analysis and Thermal Conductivity Measurement of Ceramic and Polymer Sample. Meet my teammate. My name is Aisyah Abdullah and my friend Aina Izhar and Shazwani Shamsor. For the abstract, the study aimed to understand the structural and thermal characteristics of ceramic and polymer sample through phase analysis and thermal conductivity measurement. X-ray diffraction was used to identify crystalline phase in the sample, while Liddy's method was used to measure the thermal conductivity, and the results show the ceramic sample had semi-crystalline phases while polymer sample had crystalline structure. Our experiment has two main objectives. First, to determine the phase composition of ceramic and polymer sample through X-ray diffraction method. This objective focuses on identifying the crystalline and amorphous phases in the sample, which will help understanding their structural properties. And the second one is measure the thermal conductivity of ceramic and polymer sample using Liddy's method. This objective aims to quantify how well the material can conduct heat, which is crucial for the application in various industries. This is the reason why we use SRD method to analyze the phase analysis in our experiment. This is because SRD is non-destructive, meaning samples stay intact during the study. It is a favored method for metal analysis. So the crystalline structure of the sample is then determined by analyzing the interference pattern that occur, which might provide details about the material composition and characteristic. And we use Liddy's method to determine the thermal conductivity. Since our sample both are insulator, the most convenient and quick method for determining the thermal conductivity of insulating material is to use a heat flow meter system. So this describes device that have flat, often square sample placed between a two metal plate, and the heat flow is determined by two sensors between the sample, and each plate will use the temperature sensor, which is LM35, and not the real thermometer. Now we move to the methodology part. So this is the first part, which is thermal conductivity. For figure 1 show Liddy's method setup, and to figure 2 show the schematic diagram of Liddy's method setup. Before we continue our experiment, we have to prepare our sample first. So this is our sample, which is PVC. After that, prepare our sample, we can continue our experiment. First, connect the LM35 sensor to the Arduino port for the top disk and the bottom disk. Next, Arduino was connected to computer using USB cable. And before place it, cover both LM35 by using a paraffin oil to make sure good thermal contact. Then, both LM35 were placed in the metal and the bottom disk. The power supply was turned on to heat the disk. Then the power supply was turned off until temperature showed 65 degrees. The value of time and the temperature T1 and T2 will be generated on the sensor nano net bin by using gene and U plot. We can determine the graph, and the thermal conductivity values can be calculated straight away by using a formula. Now, we move to the second part of our experiment, which is phase analysis. First, we prepare the sample in a form of powder. We grind our sample by using mortar and grinder. So this is our sample after we grind the ceramic bars. Next, we send our sample and the disk to SRD laboratory. The function of the disk is to store our phase analysis data. Then, after that, we can plot our graph intensity versus two data of ceramic for peak analysis was plotted. And then we get the specific composition in our sample.
Figure 1 shows temperature data collected for the ceramic sample. Okay, next figure 2, which is temperature data collected for the PVC samples. Okay, so for the analysis, we use the following calculation to calculate ceramic and PVC or polymer sample of thermal conductivity. As we know, K is equal to P multiplied by D and divided by the area multiplied by the temperature difference. Okay, so first of all, we need to calculate the power. Since V is the voltage across the heating element and I is the current, so P is calculated as P equal to VI. Then we can get the value of P, which is 9.35 watt. Next is about calculation of thermal conductivity for ceramic. As we know, we need to use the same formula as before, which is K equal to P multiplied by D divided by the area multiplied by the temperature difference. So we can get the value of K for ceramic, which is 52.82 watt per meter Kelvin. So using the same step, we calculate thermal conductivity for PVC. So we can get the value of K for PVC, which is 49.89 watt per meter Kelvin.
Okay, now we're gonna look onto the precaution of the Lidis method that we done during the experiment. So calibration of temperature sensor, which is LM35, was done before the experiment was conducted. The calibration data was run and recorded for the first few seconds to really check the usability of our LM35, and also the placement of insulator, which is wood, placed on the heating element to minimize the energy loss in terms of heat. Okay, now for the XRD part. Okay, we done our XRD analysis during the specific software, which is tools for our XRD analysis. Okay, as you can see now, we are picking the element that might be in the composition of our ceramic and polymer materials, which is also the element pick is based on the past research paper or past few experiment that was done on the same material. Okay, now for the XRD part. Okay, we done our okay, now this is our graph obtained from the XRD analysis. Okay, so for ceramic, this table shows the peak information on the ceramic composition. And if you can see, there is one obvious peak which shows the crystallinity properties, and also if you can see there is one green line which is we call as amorphous halo, to really shows that our ceramic sample has the amorphous properties also. Okay, so now we can see the ceramic composition. So based on the few past research paper, there should be silicon dioxide and also iron 2 oxide. And based on our XRD analysis, there is the existence of these two elements in our V ceramic composition. That means there is similarities in the chemical composition from the past research and also our sample. Okay, now this is the result, the graph obtained from the polymer analysis. So the table shows the peak information on this polymer sample. As you can see, there is one obvious peak, and also the orange line mark is also show the tiny gap of amorphous halo. That means this polymer have both amorphous and also crystallinity properties, but the amorphous halo is very low in interval. Next, for polymer composition, there should have vinyl chloride element in the PVC sample, but however our PVC sample does not have this vinyl chloride element, which is also might be due to the reconstruction of change. Based on the few papers that we read, there is a reconstruction of the PVC from amorphous to crystalline. So it was believed that our polymer composition does have the crystallinity properties, because at the peak there is no vinyl chloride but have supercuban and also calcite observed. And also, for the conclusion, the thermal conductivity The Lidis method is suitable for insulator material. For the material with low thermal conductivity, for ceramic, the thermal conductivity is 52.82 watt over meter Kelvin, and for PVC is 49.89 watt per meter Kelvin. And first, for phase analysis, the XRD is the suitable technique for us to know the sample's composition. And also, main composition of our ceramic vase sample is silicon dioxide, and it is believed to have the semi-crystalline properties due to its one sharp peak and wide amorphous halo. And also, main component for PVC is calcite and supercuban, and it is believed to be a crystalline due to its one sharp peak and very low amorphous halo. That's all from us. Thank you.